This video is going to cover Unit 14.7 and 14.8. 14.7 is the solutions of equations by the root principle of equality. The root principle of equality states that if the same root of both sides of an equation is taken, the sides remain equal and the equation remains in balance. The root principle is used to solve an equation that contains an unknown that is raised to a power. For example, s squared is equal to 36. Okay, so let's talk about radicals before we get into this. Now, what is a radical? A radical is a symbol that looks like that. Now, when we take the square root of a number, we'll call it x for right now, we do not generally write the 2 right there. In math, there are a lot of numbers that we don't write. We don't write the power if it's raised to the first power, and we don't write, like say, number 5 as a fraction of 5 over 1. One of the other numbers that we don't write is when we're taking the square root of a number. When we are taking the cube root or any other root other than a square, we write the number right there. So we can make the assumption that that number right there is a 2 if it's not written. So let's take a look at example number 1 on page 438. We have x being squared is equal to 25. Now to find x, we do the opposite of the square, which is taking the square root, not writing the square right there. Whenever we take the square root of something being squared, we have what is under the radical. So in this case, we would have an x. Now if I take the square root of one side, I have to take the square root of the other side. And the square root of 25 is 5. Now we can do that on our calculator. So let's take a look at, most of you might know that the square root of 25 is 5. Well, what's the square root of 75? You know, stuff like that. We might have to use our calculator. So let's take a look at some of the buttons that we'll be using on our calculators for this. Right here. Okay, that's good. All right. So here we have the square root symbol right there. I have to hit the second function in order to get to it. And right there I have the cube root. Now, all scientific calculators will have the square root and the cube root. I'll also have this one right here. I'll talk about that in a few seconds. On your TI graphing calculators, or maybe even if you have another kind of graphing calculator like the Casio or something like that, you may have to get into some menus in order to see the cube root. The square root will most definitely be out on the surface, either used by a second function or right straight on one of the buttons. But generally speaking, on those graphing calculators, they're menu based, and anything other than the very normal things that you use, you have to use a menu in order to find them. But it'll be in there. On the TI calculators, I believe you have to hit math. I don't have one in front of me, but you have to hit the math button and then scroll through one of the menus, and it's there. I don't know off the top of my head. I can find it if I had one in front of me. But that's the cube root. That's the square root. And this is anything else. So if I wanted to take, say, the 5th root of something, I would use that one. You could use it for square root and cube root too if you really wanted to. But in order to use that one, you would hit, like let's say I wanted to take the 5th root of a number. So I'm hitting 5 on my calculator. Then I hit second function, and then that. And so my calculator looks like that right there. So if I wanted to take the 5th root of 968, like that, and I hit equal. So I would round that to 4. So the fifth root of 968 is 4. Now using the cube root function, you would not have to hit the number first, or the square root, you wouldn't have to. So let's take a look at example number 2, where it says we have a cube. Now by definition, a cube is going to have 3 sides, and all the sides are going to be equal. So we have a cube that has a volume of 164.3 cubic centimeters, or centimeters cubed. And we want to find out what each side is. So I would come here, and I would use that button right there. So I have to hit second first. So I hit second, and then I hit that right there. And I've got the cube root, so then I type in 164.3, and my calculator looks like that right there. And then I hit equals, and it looks like each side of that cube is about 5.48, maybe 5.5, depending on exactly how close you want to get. Now we don't talk about how to round in this. We don't talk about significant figures and stuff like that in this class. Maybe I will in the future. But so rounding. Students always ask me how far to round. Round to 2 decimal places or close to that. So I would accept answers as 5.5, 5.477 even, 5.478, something like that. Not 5.6, however, and probably not 5.4. Okay? All right, so let's go back out to what we would call normal, or close to normal anyway. All right, so continuing, let's take a look at, in the exercises, I want to look at number 23. Let's talk about some fractions. Ooh, everybody loves fractions. I like fractions part of the time. So that's a negative 1/8 is equal to y cubed. Okay, so this is cubed, so I need to take the cube root of it, and so that's going to give me y. Well, I need to take the cube root of this side. Now when you're taking the cube root of a negative number, it's going to be negative. So I'm going to put the negative right there, and then the cube root of 1/8. Now remember your rules for radicals. If I'm taking the root of a fraction, I can take the individual roots of the numerator and the denominator. And it's going to be negative. So the cube root of 1 is, I'll put it over here. Cube root of 1, oops, that shouldn't be there, is 1. And the cube root of 8 is 3. Now you can, or 2 rather. You can, so y is equal to 1/2. You can do it on your calculator, but if you happen to know that the cube root of 8 is 2, you can just say it. Now let's take a look at let's take a look at number 30. That looks like a good one. So number 30 on page 439. 0.0017 is equal to Oh, that wasn't the one. I wanted 33, not 30. Yeah, that's a fourth root. So 33, sorry about that, 8.794 is equal to f raised to the fourth power. Now this is on that calculator, so I need to take the fourth root of that side is going to give me f, and I need to take the fourth root of this. This is where on your calculator you're going to use that button right, oh, it's not going to focus. There it goes. Going to use this one. So first thing I need to do, I know you can't see it, so I'm focusing on that, is I'm going to hit the number 4, and then I'm going to hit second function, and then that button. So what that looks like on my calculator is that right there. And then I'm going to hit 8.794 and 1.7. So 1.7. Let me get back out to normal-ish. Zoom. So F is equal to 1.7. So there's an example where the power is higher than 3. Let me see if there's another one in here that looks good up there. Yeah, number 16. Let's take a look at number 16. That's an interesting looking one. T raised to the third power is equal to 0. Now this is a complicated one. So I have to take the cube root of t and the cube root of 0. The cube root of t cubed is just going to be t, and the cube root of 0 is 0. Any root of 0 is 0. So it's not really that complicated. All right, so let's take a look. Let me see if there's another one in here. No, let's go ahead and go to 14.8. Okay, 14.8 is solution of equations by the power principle of equality. The power principle of equality states that if both sides of an equation are raised to the same power, the sides remain equal and the equation remains balanced. The power principle is used to solve an equation that contains a root of an unknown. For example, the square root of a equals 8. Okay, so as you've noticed, these are all been inverses of each other. So we did the addition principle and the subtraction principle, then we did the multiplication and division principle. Now we're taking the root and the power principle. They're opposites of each other. Okay, so let's say we have, let me see here. Let's example 1. Let's go ahead and just talk about example 1 real quick, where it says the square root of y is equal to 3. So just like before, when I took the square root of something being squared, I got what was underneath the radical. So if I'm taking the square root of something, if I square that, I'm going to get what's under the radical. So if I square this side, I have to square this side, and 3 squared is 9. Same thing is true for any of the powers. So let's say, let's see if I can find one, a good one here. Looking at number 16 on page 441. 16 is m to the fourth power is equal to 2. So I'm raising that to the fourth power, so that gives me m on this side. And I'm raising 2 to the fourth power as well. Now, in your calculator, you can just say 2 times 2 times 2 times 2 if you want to. That's okay. However, to use the calculator properly, what if it's like raised to the, I don't know, let's say something ridiculous like the 30th power. You don't want to keep doing all that. So, let's zoom in again here. Let's take a look at some of our numbers that we have to use. Right here, these are the two numbers I want to look at. So here is if we're going to square something, we can hit this button right there. So 5 squared, I would hit 5 and then hit that button right there, and I get 5 squared. So this button right here, I can raise any base to any power. So what we have here is 2, so I will hit 2 first. And then I hit this button, and then what that looks like is this right here, and then I'm raising it to the fourth power, so I hit 4, and then hit equals, and right there, 16. 2 raised to the fourth power is 16, so therefore m is 16. Let's get back to something normal, right there. So m equals 16. So that's how you use some of the buttons on your calculator. Now, any scientific calculator is going to have these buttons, but like I said, generally speaking, your graphing calculators will have a number being cubed and a number being squared on the face. But anything else, you would have to search in your menus for that. So if you have a calculator and you're not quite sure where to find some of the buttons on it, or if the buttons are either there, you can Google it, or you can just send me an email and ask me, tell me what your calculator is, your model number and make and model number, and I can look it up, or maybe I might just happen to know it, because I've used several, especially the TI calculators. I've used the TI-82, the old TI-82s, all the way up through, I don't know, the 89s for calculus and stuff like that. All right, so let's see what else we have in here, if there's any other really good problems that might look neat. Number 35 is the same. 36 is a fifth, so 36 looks like this. I take the fifth root of x, and that is equal to 12.04. So that means I have to take the fifth power of that and the fifth power of that, and then I can just do that on my calculator using that same sequence of numbers. I hit, let's see, I gotta hit my base first, so 12.04, and then the y raised to the x power, and then hit 5 on that, and so that's gonna be, x is gonna equal a lot. 253,006.9. Close enough.